Hey folks, this is Mr. Carey, and I'm coming back to you with our last video in the Chapter 5 review test, or test review, whatever you want to call it. So, if you are joining us, we left off on page 230. We finished 230, and now we have the number 231 and page 232. So, and these ones are a little bit less detailed than the first two and the middle two pages. So this should go pretty quickly. But again, in Mr. Carey's usual way, how I over-explain things may take a little bit longer. So without further ado, let's go ahead and start off with number 17. So Winnie wrote the following riddle. I am a number between 60 and 100. Excellent. Now, my ones digit is 2 less than my tens digit. And I'm a prime number. Okay, so we've got a few things that we're working with here. Between 60 and 100, so I'll write between 60 and 100, my ones digit is 2 less than my tens digit. So for those that are dabbling in a little bit of algebra, if I have my ones and my tens and my hundreds, right, it probably looks something like this. If I have my tens was x, then my ones would be x minus 2. For those that have no idea what I'm talking about, that's okay. Some of you may have been exposed to this. But this is just me saying, I don't know what my tens digit is. But whatever it is, my ones is going to be 2 less than the tens. And I'm a prime number. So there's a cool way to do this. And you just start with 90, 80, 70, and 60. Because we know it can't be 100, it has to be less than 100. And we can do 60 just to show you, but let's start off with, we'll start with 60. Okay, so if 60, right, my ones digit is 2 less than my tens digit. So if my tens digit is 6, what would be 6 minus 2? That would be 4. Okay, so 64. And then we're not going to mess with which one is which right now. We'll do 70. Okay, so if my tens digit is 7, what is 2 less than 7? 5. Okay, now we have 75. Let's do 80. What is 2 less than 8? 6, correct. And we can kind of see a pattern growing here. Hopefully we do. And if we don't, I'll point it out to you. We have 90. Okay, so 9, and then 2 less than 9 would be 7. Now, you can see the pattern here, right? 4, 5, 6, 7, and then it keeps going here, 6, 7, 8, 9. All right, just counting up. All right, now if you are like, well, Mr. Carey, you have not taught us what prime numbers, you've taught us the first 10 prime numbers, but we have no idea. Well, let's use a little bit of process of elimination here. Let's do the ones that we do know, okay? Any number that's even, with the exception of 2, is going to be a composite number because I can divide, for example, I know my factors of 64 are 1 and 64 or 1 and 86, and I know I can use 2. I know I can divide 2 into 64. I have no idea what it is, but I know I can do it because 2 is an even number. If I count up high enough, I'll get to 64. Same thing with 86. So I know that it can't be 64 because that's a composite number, and it can't be 86. Okay? They're divisible by 2 and they're even. Let's go over to 5. Well, it's not divisible by 2, but one thing I can do is it's divisible by 5, because if we remember our divisibility rules, anything ending in a 5 is going to be divisible by 5. And I can count up enough, 5, 10, 15, 20, 25, 30, 60, 65, 70, 75. So I know I'm going to at least have 1, 5, and then 75. So I have more than 2 factors. And then at a process of elimination, that just leaves 97. So even if you didn't know 97 is a prime number, well, now you do. It's a prime number. It's the only 97 is her answer, and then you have to explain, okay? So this is where you just have to walk me through what you just did. You can say 64 and 86 are even and divisible by 2. They are composite numbers. And then you can go on to say 75 is divisible by 5 and is a composite number. That leaves 97, and the only factors of 97 are 1 and 97. Now, how do I know that? Because I've tried dividing, and you can do that too. If you really don't trust me, you can start with 97 and start dividing 2 into 97, 3, 4, 5, 6, 7, 8, 9, and see if you get a remainder. I guarantee you will get a remainder, which then tells us that 97 is a prime number. All right, so 97 is your answer. Number 2, so Winnie's friend Marco guessed that her riddle was about the number 79. So now you need to tell me why Marco is not correct. Why can't 79 be the answer? And this is really, it does not matter if 79 is a prime number. It is, but it doesn't matter, right? All you have to look at is the rule. What is Winnie's rule? The ones digit must be 2 less than my tens digit. So this is where you just explain Winnie's rule is the ones digit must be 2 less than the tens digit. And then you just tell me, I mean, obviously I know, right? Mr. Carey knows that 79 is not correct, but I want you to tell me why you think it's not correct. In the number 79, the ones digit is 2 more, and I would probably even put more than the tens digit. If you left it like that, then you are totally correct, because then I can go, if you can say it should, right, be 2 less. That's fine. And that's it, really. It has nothing to do with the fact that it is a prime numbers between 60 and 100. It's just that it didn't follow Winnie's rule. And you give me that, boom, you get full credit. Okay, next. All we have to do is sort out these ones, number 18. Classify the numbers as prime or composite. So again, start off with the easy ones that we know. Okay, make it easy on yourself. Don't struggle with 37 and 71 if you're not sure. Let's start with 65 and 82. Well, I know if we use the same rules we did, the divisibility rules we used in part A, that's a really messed up arrow, isn't it? I'll do that. If we use the same divisibility rules, right? Well, 82 is even. It's divisible by 2. 65 can be divisible by 5. So we know those are composite. It doesn't matter if I don't know 5 times what gets me 65. I know that I can divide 5 into 65. So now we're left with our prime numbers, maybe 37 and 71. All right, and then here, you have to break out your divisibility rules. I know 2 won't work, and what I would probably do is I take 37 and 71, and I'm going to write down all my numbers, 3, 4, 5, 6, 7, 8, and 9. And then I just start going through my rules, right? I know it can't be 2. It's not going to be 4, because 4 is even. It's not going to be 6. Not going to be 8. Okay, so now I'm left with, let's do 5. Well, it can't be 5 because it doesn't end in a 0 or a 5. We can try 3, but remember, my divisibility rules say add up my digits. 3 plus 7 gets me 10. Is 10 divisible by 3? Nope, it's not. And then what about 9? We use the same thing. 3 plus 7 gets me 10, and now you divide it by 9. That doesn't work. And now I'm left with 7. And then for divisibility rules with 7, they get kind of complicated. So this is where you just want to break out your old friend long division. So 7 goes into 37. How many times? Well, we don't know. What gets me close? 5. So 7 can't go into 3, but 7 can go into 37. So 5 times 7 is 35. Subtract 7 minus 5 is 2, and now I'm left with a remainder of 2. And guess what? That is not divisible. Doesn't matter that I have a remainder. That is not divisible. So we know 37 is a prime number. And now do the same thing with 71. 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm sure some of you are saying, Mr. Carey, do I really got to do this for like every problem? My answer would be, yeah, I probably would, like if you want to get a good grade. Because the more you do this now, the easier it'll be when you get into the later chapters. And then this just becomes muscle memory. So let's look at 71. 71 is an odd number. So 2 won't go, 4 won't go, 6 won't go, 8 won't go. 5 won't go because 71 does not end in a 0 or a 5. Let's do 3. Remember, 7 plus 1 gets me 8. 8 divided by 3 does not divide evenly. Do the same thing with 9. 7 plus 1 is 8. 8 divided by 9 is not a whole number. That doesn't work. And then now let's do our old friend, long division, 71. 7 divided by 7 is 1. 1 times 7 is 7. Subtract, 7 minus 7 is 0. Bring down 1. And then 7 goes into 1 how many times? 0 times. 0 times 7 is 0. 1 minus 0 is 1, and I'm left with 10 with a remainder of 1, which means it is not divisible. So we have our answer, 37 and 71. Excellent. So it's just a good review of divisibility rules. I would recommend, really just to keep your thoughts straight, really lining your divisibility out this way, especially when you're trying to figure out if it's a prime or composite number. All right, let's go on to number 19. Erica knits 18 squares on Monday. She knits 7 more squares each day from Tuesday through Thursday. How many squares does Erica knit on Friday? Okay, so now you just need to start off with, let's do Monday, and this is where I would say Monday. Let's do it in black. Do Monday. And I'm going to do Tuesday, I'm going to do Wednesday, I'm going to do Thursday, and then we'll have it by Friday. Okay? All right, Monday, we know, and I'm going to do a different color here. Monday, she did 18 squares, and then she knit 7 more squares each day. So this will be plus 7, plus 7, plus 7, and then plus 7. So 18 plus 7 is what? 25. And then we have to do 25 plus 7, which is, I'm just waiting for anybody to, so 25 plus 7 gets me 32, correct? 32 plus 7 is 39. And then 39 plus 7 gets me 46. So by Friday, she has knitted 46 squares. So really something like that. Like, don't try and do it in your head. Really line it out. Monday, Tuesday, Wednesday, Thursday, Friday. That way you can see the pattern and you're just adding plus 7 at the end of each day. Excellent. Now, number 20, use the rule to write the first 5 terms of the pattern. Okay, so my first term is 11. And then what's next? So we have to add 10, subtract 5. So add 10, 11 plus 10 is 21, subtract 5, 16. So it looks like add 10, subtract 5. And I'll do my little thing I like to do here. And let's do add 10, so 16 plus 10 is 26. And then 26 minus 5 is 21. And that's your first 10 or your first 5 terms. 11, 21, 16, 26, 21. That's it. So really, again, using any sort of patterns, it's best to try and not do it in your head and just line everything out on the paper. All right, we're going to turn the page here. So I'm going to do, hopefully you have everything. If not, now's a good time to press pause. And I'm going to make my other page 232 appear right now. All right, so we are back, page 232, and this looks like Alina and we're at the home stretch here. Alina has 10 tiles to arrange in a rectangular design. She drew a model of the rectangle she could make with the 10 tiles. So how does Alina's drawing, looking at part A here, how does Alina's drawing show that the number 10 is a composite number? So you just need to define what a composite number is. Now, what they're showing us with the drawing is that there's more than one way to arrange rectangles with 10 tiles. So you can say you can do this 2 ways. There are more than 2 factors of 10. 1, 2, 5, and 10. Okay, that's one possible answer, and that's a good answer. Like, I would accept that. But if we're going to keep it in terms of rectangles, you're just going to tell me there are 2 possible rectangles that can be drawn with 10 tiles, meaning there are more factors of 10 than 1 and 10. And that's it. So that would be your answer. That's just explaining to me that you know what a composite number is, especially when they start throwing in pictures like this. Okay, so now, suppose Alina used 15 tiles to make the rectangular design. How many different rectangles could she make with the 15 tiles? Okay, so this just means, and I'll translate this again. So translation, factor out 15. Draw pictures or list the factors. That's all it is, right? Suppose you use 15 tiles. Let's just say I have a number 15, factor out 15. Okay, so, but I also want to see the dimensions too. So if you just give me the list, that's fine. But I'm also going to want to see your factor pairs. So don't give it to me in a list, give it to me in factor pairs. So the answer, right, I have 15 tiles. So what are the different ways I can factor 15? Okay, you can write like this. You can do 1 and 15. And then the other way would be 3 and 5. And that's it. One tile and 15 tiles. 3 tiles and 5 tiles, right? So if you're going to draw this out, it's really just going to look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then if you're drawing out, that's your 1 and your 15. Then your other way is 1, 2, 3, 4, 5, 1, 2. And all I'm doing is just drawing out my boxes here. So then I have 3 by 5. That's it. Or you can say 15 and 1 and 5 by 3. But that's all that they're asking you to do in part B, is just take 15 and factor it out. And then and then show me your factor pairs. And then part C is pretty cool, because this is just Luke kind of bragging that he can make more rectangles with 24 tiles than with Alina's 10 tiles. Do you agree with Luke? Well, okay. Let's start with how many factors we'll put Alina, right? Alina, how many factors does she have? 4 factors, 2 rectangles. I'm going to erase my little right there. So she has 4 factors, 2 rectangles. That's it. Now let's look at Luke. We don't know about Luke yet, but we know he has how many? Well, he's got 24 tiles. So let's do this factoring. Let's do our factor pairs first. So I have 1 and 24. Now let's do about 2. I know 2 and what? Good, 12. About 3? Sure. 8 times 3 is 24. And what about 4? Sure, 6 and 4 is 24. 5 doesn't work. And so we're done factoring out. These are my factor pairs. So Luke, how many factors does he have? 1, 2, so we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. And this is where I write 8 factors. And we have 1, 2, 3, 4 rectangles. Excellent. Now, is Luke correct? Yes, he is. And then now, of course, you need to explain. And it's all you're doing is explaining, showing me what you have, right? So you could say something to the effect that 24 has more factor pairs than 10. 24 has 4 factor pairs, and 10 only has 2 factor pairs. This means I can draw 4 rectangles using 24 tiles. I mean, that's a really detailed explanation. If you just stopped at 24 has 4 factor pairs and 10 only has 2 factor pairs, I'd be fine with that. But if you want to go that extra mile and push yourself, then throw it out. That just means you're making that connection to if I have 2 factor pairs, or if I have a factor pair, this is 1 rectangle. And that's 1 rectangle. And that's 1 rectangle. And that's 1 rectangle. And then add them all together and I have 4 rectangles. And that, ladies and gentlemen, takes us to the end of our Chapter 5 review. Hopefully, these 3 videos taken together will help you out in preparing for your Chapter 5 test. If they did, great. Go ahead and like this. Leave a comment down below if you liked it. If you haven't subscribed yet, now is a great time to subscribe because we've got more great videos coming up. And if you didn't like it, that's okay. But just tell me why you didn't like it. What was unhelpful for you? What could I have done better? But our next video should be the Chapter 6 mid-chapter checkpoint. So if you have not seen that yet, make your way over, look for it, and then after that we will have the Chapter 6 review. Same thing, I'll break it up into 3 videos. Should be helpful in reviewing your fractions. But for now, this is Mr. Carey signing off. Any questions, comments, concerns, likes, dislikes, leave them in the comment section. And I will see you all next time. Bye.